welcome back everyone to Forward CloudSec. Before we get to the next sponsor, we would like to, before we get to the next talk, we would like to thank our sponsor, OpenRaven. OpenRaven is the data security posture management company for security teams with modern cloud infrastructures needing to locate and secure sensitive, toxic, and exposed data across clouds at petabyte scale. Enter our Steam Deck raffle, www.openraven.com/Valve Steam Deck. Winners will be notified after the event. With that, we'd like to introduce you to our next talk, Scanning the Internet for External Cloud Exposures with Nir Ohfeld and Hillai Ben-Sasson. Thank you, Nir and Ben. Hillai.
Thank you. Hello, everyone. Welcome to our talk, Scanning the Internet for External Cloud Exposures. My name is Nir Ohfeld, and here with me on stage is Hillai Ben-Sasson. We are both security researchers, a part of Wiz research team. And now you might be familiar with some of our work, notable cloud incidents like ChaosDB, Oh My God, Ping Bang, and more. And we actually have more findings coming out soon, so stay tuned about our blog. Now, in the recent months, we've been delving into the world of external cloud exposures. And if you're anything like me, when you think about external cloud exposures, you immediately think about exposed S3 buckets. And honestly, I cannot blame you. In the recent years, there have been a ton of incidents involving data leakage caused by improperly configured S3 buckets. But when we started this research, we thought, storage is not the only service offered by major cloud providers. And there's a ton of other services that can be misconfigured to be exposed to the internet. For example, SQS, Amazon's leading queue service, can be exposed to the internet simply by pasting the asterisk character in the pre-simple field. Or you can expose your SNS topic simply by pressing two buttons. And the competition is no different. Azure also have very creative ways of exposing your data to the internet in the form of Azure SAS tokens. Azure SAS tokens are essentially a pre-signed URL used to access Azure storage resources. And Azure storage is much more than just files. It can be used to store files, but it also can be used to store queues and tables. And the pre-signed URL scope can be anything from one single file to the entire storage account. And this is how it looks in action. These are the default settings for generating a new SAS token. As you can see, the default access is to the entire storage account, including all of the files, queues, and tables. And the permissions are essentially admin permissions, granting read, write, delete, and list. So, after generating the new SAS token, I'm left with, And when it comes to the expiry, where AWS S3 pre-signed URLs are capped at 2 weeks, Azure gives its user much more freedom. And when it comes to the expiry, the sky are essentially the limit. So now, when I press the Generate SAS Token button, I'm left with a pretty easy to share URL. And anyone that gets its hands on this URL has a complete access to my Azure storage account. So you would imagine that this kind of a powerful URL I will be able to track it somewhere in the Azure portal or via public API. But you'll be wrong, because there's actually no official way of tracking Azure SAS tokens. And we've actually witnessed companies track these using Excel spreadsheets. This is how bad it gets. Now, but let's assume that you have a perfectly configured AWS environment, and no resource is exposed to the internet. But now, one of the software engineers in your company is tasked with building a mobile app capable of uploading files to a private S3 bucket. The engineer is left with a choice of how to implement it. He can either set up a web app server that will serve as a proxy between the mobile app and the S3 bucket. This proxy server will be equipped with AWS credentials, and the mobile app will upload it to the server, and the server in turn will upload it to the S3 bucket. But this means that the engineer now has yet another liability, another server to maintain, and another set of AWS credentials to track. And he probably wouldn't want that. So he can just expose the S3 bucket to the internet. But if you learned anything up until this point of the presentation, you probably know this is not a very good idea. So he can do what AWS recommends him to do, and needs to use AWS Cognito identity pools. For those of you who are not familiar with AWS Cognito identity pools, they're essentially an easy way for websites and applications to interact with internal AWS resources. This is done by granting the application temporary AWS credentials for external users. Those users can be either authenticated users or unauthenticated users, also known as guests. So in this new architecture, this is how it looks like. Our app will first contact the Cognito service, getting the temporary AWS credentials, and using these credentials, it can now log into the internal AWS environment. But this means that all of the AWS resources that up until this point were private are now exposed to the internet. So when we set out to do this research, we said that other than just scanning for open S3 buckets and SQS and SNS, we'll also scan for Cognito identity pools, because it provides us a much larger attack surface. But this is easier said than done, because scanning for all of these resources is quite a very difficult thing to do. For instance, one reason is because each of these resources has a different kind of identification mechanism, where an S3 bucket is essentially a domain, and SQS queue and a SAS token are both full-blown URLs, or ARNs. And when it comes to Cognito, it's just a UUID. And how are we even going to go about scanning the cloud resources of other companies? I mean, those resources are scattered all across the internet. How should we, as a private company, scan the entire internet for cloud resources which we don't have access to? Well, to answer this very question, I would like to invite my very good friend and colleague, Hillai Ben-Sasson.
Thank you, Nir. Now that we've seen how those resources look, let's talk a little bit about how to find them. You know that feeling when 3 years ago you created some file on your computer and you just know that it's there, but you have no idea where you put it? In that case, would just grab your computer, right? Well, I know that there are some cloud resources scattered around the internet that will topple empires if they fell to the wrong hands, but I don't know where to look. So how can I grab the entire internet to find the things that I'm looking for? Well, until we can run this command, here's what we did do. Let's start with S3 buckets. This is what an S3 bucket looks like, right? It's bucket name.s3amazonaws.com, meaning that's essentially a domain. So if we want to look for domains, we first have to ask ourselves, where do we find domains? And in order to ask ourselves this, we have to ask ourselves, where are domains born and die? DNS, right? Well, enter passive DNS. What is passive DNS? Apparently, your ISP has more income streams than just your monthly bill by selling your data to various third parties. And passive DNS are databases of DNS queries that people online are making constantly, sourced from ISPs, hosting providers, enterprises, etc. Basically, it can provide you with an image of what domains people online are looking for right now. So we wanted to use this database as a way to find public exposed S3 buckets. And this is how we did it. We started out by taking out a sample of about 2 weeks of passive DNS data and filtering out S3 domains only, meaning the domain you saw earlier, .s3amazonaws.com. That gave us with 1.7 million potential bucket domains, which is a lot for just 2 weeks, meaning it's a very powerful source. So out of this sample, we took a sample of about 100,000 domains for the scan. And we started basically performing HTTP scans on them, probing them online to see what type of responses they're returning. We then took out all the responses and started to throw away all the non-existent buckets, any non-existing domains, typos that people online are making. As it is with those types of databases, naturally, some part of the data will be garbage. So after throwing out the garbage, we were left with valid S3 buckets found online. Then the final thing we did was to filter out all the private buckets. Anything that gave us an access denied, didn't allow us to list the files, didn't allow us to read the files, those were not really of interest to us. And after that, we were left with only publicly exposed public S3 buckets, which is what we were looking for. Now, the numbers here were quite shocking to us. Out of 75,000 private buckets, we found 12.3 thousand publicly exposed buckets, which is a lot. It's about 14% of the buckets we scanned at this sample only, meaning that it's far from being a dead problem, although it's being talked about all the time. Let's talk about the competitors. An Azure storage domain with a SAS token might look something like this. It's account name .bobcorewindowsnet/container name !SAS token. All right. This is a full-blown URL, meaning that DNS records from before aren't enough. Knowing just the domain part of this URL will not help me access those protected files. So if we want to look for SAS tokens, we asked ourselves, where do we actually find SAS tokens in the wild? Well, they might be in images, static image content that websites are hosting. They might be in links. If you want to link like a document or a spreadsheet to something, you might host it on Azure Storage. But Google Search won't help me with any of these because they aren't really text. They're HTML content embedded on the page. So we wanted to find out some other source that will allow us to not only look through the textual part of the page, but also to look at the HTML content of the page and search for the data that we're interested in. Enter Common Crawl. Common Crawl is sort of an open source index of the web. Like Google, it constantly probes the internet for public web pages. But unlike Google, they don't just expose some simple search interface. They allow you to view the raw data as is. It's open source that anyone can access it and do with it as you please. It's a very, very big index, actually. They have over 74 billion unique URLs index and over 7 petabytes of raw data to look for, which is a lot. But luckily, there's this guy named Andres Riancho, hoping I'm pronouncing this correctly, which made a very interesting talk about this a Black Hat a while back. This is the name of the talk and the link. I highly recommend you check it out if you're interested in this. And he basically did a lot of interesting work about how to utilize the power of the cloud, specifically AWS Lambdas, in order to comb through these huge troves of data with relative ease. He also released a couple of cool open source tools that allow help with these. So I highly recommend checking out his GitHub. He has a lot of other cool projects as well. Shout out to Weef. And thanks to the work of this talented researcher and this amazing organization, we can essentially grep the internet, or at least a very big chunk of it, for the SAS URLs we wanted to find. So this is what we found when we looked through about 40 millions of Common Crawl website data. We found about 7.7 thousand unique valid SAS tokens spread across 274 storage accounts. And out of those tokens, we found 526 exposed storage containers owned by 79 different storage accounts. That means about 29% of SAS token users we scanned had highly permissive configurations. And what does highly permissive configurations actually mean? Well, some of these tokens allowed us access to more containers than just the containers hosting the file. Imagine an engineer trying to expose images, static images to view on his website, and accidentally also exposing an adjacent container containing user invoices. Some of those, in addition to this kind of exposure, also allowed us write and delete access to files that should have been only readable. Imagine an attacker, just by viewing the URL on your page, being able to delete and modify the images and the static resources on your website. All right, now that we've talked about these resources, let's talk about a more complicated type of resource, cognito identity pools. Cognito identity pools can be found on the web, but not exclusively. Like Nir mentioned earlier, many mobile developers utilize these sort of services for purposes of SSO, for purposes of identity providers, or just to expose AWS resources to the app. And we wanted to find out those as well. So how can we scan, for example, the entire Google Play Store to find cognito identity pools? Here's how we did it. We started out by narrowing out the source of the power. The Google Play Store is huge, and they don't really want you to scan through all of it. So we wanted to filter out only apps that use the AWS SDK. An SDK is essentially some sort of developer toolkit that Amazon releases to make developing with AWS resources easier. We figured out that if app developers are using Cognito, they would probably use it through the official AWS SDK instead of rolling out their own code. We were left with this list that narrowed the scope of the problem to something that we can handle. So we took out all the names of those apps and downloaded them from various third-party sources, APK Mirror, APK Pure, etc. Since Google Play has protections against that kind of scraping as well. We had all those apps on our system. We started to decompile them from APK, which is the compiled version of an app, to Smalley code, which is a textual representation of the Java bytecode that powers the app. And when we had the textual code, it was much easier. We just had to look for what we're looking for. We took all the textual code and we scanned it using ripgrep, which is like grep, but actually good. I'm kidding, grep is the reason I have a job. I love grep. But ripgrep is a rewrite of grep using Rust, which is really, really efficient for coming through huge troves of data. So if you're looking for 40 terabytes of Smalley code, this would be an ideal tool. We used it to search for AWS ARNs, AWS URLs, those sorts of resources hiding out the code. And then when we had those resources, we just did what we did earlier. We probed them externally using HTTP scans and utilizing the AWS API. This is what we found on Cognito. We scanned about 30,000 Cognito apples that we found. All of them are still valid. Out of those, almost a third of them allowed anonymous authentication. And out of all of the anonymous authentication apples, 1.5 thousand were over-permissive, meaning that they allowed us access to something asterisk. For example, the entire S3 access for the account, entire SNS access for the account, entire SQS, etc. Meaning that it's worth noting that with Cognito apples, each and every one of those 1.5 thousand apples is an initial access point for an entire AWS account, for an entire organization. So the impact of every single one of those could be exponential. All right, an open question to the crowd. Where else do people always put their secrets online? Exactly. Fantastic. So obviously cloud secrets are no different, and we wanted to search through GitHub data as well. So luckily, Google's BigQuery has a very large, although it's worth noting not complete, index of GitHub code in an SQL searchable format. So we can essentially query GitHub code with our own regex pattern in a very fast and also very expensive way. So now that we have all those really powerful tools at our disposal to scan the internet or grep the internet, let's talk a bit about Azure Active Directory. So if you're not familiar with Azure Active Directory, you are definitely familiar with this infamous login page. So just know that every single time a website redirects you to this login page, it's almost always powered by Azure Active Directory, which is the single sign-on / identity provider and actually much more service that Microsoft offers through Azure. Now, did you know that when creating an Azure Active Directory application, by clicking on this simple checkbox right here, the login page that you saw on the previous slide will accept logins from every single user on any Azure tenant in the world, not just the tenant that hosts the app. For example, if I'm creating an app on the Wiz.io tenant, and I click this checkbox, the login page will now not only accept at Wiz.io emails, they will also accept at Microsoft.com or Google.com or Amazon.com or any other domain that I created 5 minutes ago, .biz. And my login page will essentially just accept everyone. With this in mind, we started scanning online using all the tools that we mentioned earlier to find out all the Azure AD apps in the wild that are misconfigured like this. We found over 1,000 vulnerable Azure Active Directory applications, but in our research, we don't only care about the quantity, we also care about the quality. We wanted to find the several apps in this big list that were high impact, super important apps that should have never been exposed like this and should be rectified and fixed immediately. So obviously we could not comb through over 1,000 AD applications manually to figure out what each one of them does. So we wanted to narrow out the scope of this as well. And when we asked this question, we answered it almost instantly using one key question, which is who has the best bug bounty program that we know in the industry and is also coincidentally a very big Azure customer. Talking of course about Microsoft, which we've always had the pleasure of working with when reporting bugs. So big shout out to the folks at MSRC for cooperating with us in the past. So when narrowing out the list to Microsoft domains only, we were left with a much smaller and much more manageable list of domains to come through manually. And when we glanced at the list, the one domain instantly caught our eyes. Talking about this domain, bingtrivia.azurewebsites.net. We saw this, we instantly thought, could this be related to Bing.com, like one of the largest websites in the world that's also operated by Microsoft? Or maybe this is like coincidental. So in order to figure this out, we browsed this domain and we logged in using our own user on Azure, a Wiz research user that had nothing to do with the Microsoft tenant. And when we logged in, we were good with this page, which is, as you see, densely packed with irrelevant keywords that meant nothing to us. So look, just glancing at this, we could not instantly figure out what this app does. And we cannot figure out if this app was meant to be exposed to Hillai Wiz.io, or is it an internal app that is misconfigured. So we started probing further. We saw this section titled carousels, which had a list of what seems to be search keywords. And when we clicked on one titled best soundtracks, we found a list of what seems to be good movie soundtracks, which begged the question, could this panel, 90s looking exposed control panel, actually control live search results for Bing, or is this some sort of test environment? So in order to figure this out, we decided to edit one of the search results temporarily to figure it out if it actually affects Bing, then of course revert it. Now if you take a look at this list, you can see that this is a list for best movie soundtracks, right? And the first result here, now if you can see, is the movie Dune from 2021, which I'm sure has an amazing soundtrack. But when I think of best movie soundtracks, I think of one movie and one movie only. I'm talking, of course, about Hackers from 1995, a cinematic masterpiece. So we wanted the results to reflect that. So we edited the first result from Dune to Hackers with the name, the year, and the title. And when we clicked save, we were astonished to find this result immediately appear on the Bing.com search result for best soundtracks. So we quickly reverted our changes, reported everything to Microsoft, and worked with them to fix the issue. They were very timely, fixed everything, and also awarded us a bug bounty for some of our findings in this research. Now, the story I just told is a very, very abridged version of this entire research. There's actually a lot more that was involved, whether it was tools, tricks, and all sorts of Azure Active Directory details that were involved in this, and also some more interesting findings that I didn't cover. So if you want to find out more about this research, I welcome you to go to our Black Hat talk that we will be presenting in this August in Las Vegas, which is not a far drive from here, which will be all about this research and how we did it, the various tools and tricks that we used in this research, a deep diver about Azure Active Directory, and the findings themselves. So let's sum things up. Firstly, exposed cloud services are both very common, as you saw from the numbers that we found out on scans, and can be very impactful, as we saw on the Bing example. And scanning them with distinct tooling, while challenging, is definitely feasible, especially for a skilled attacker. Now, our research is just the tip of the iceberg on this, and I mean this in two ways. The first way is that many more cloud providers and services need to be examined. I'm sure every one of you knows that there are a lot of CSPs out there, and every CSP has hundreds and hundreds of services. Each and every one of them could be misconfigured in a similar way, and each service can be the next big problem that is lying around and nobody knows about. And the second way is that, as always, a lot more of the internet is yet to be uncovered. Thank you very much. Questions?
Thank you very much, Nir and Hillai. So if anybody has questions, sure.
Hi, thank you. So you mentioned a bit of what the follow-on was with vulnerabilities found within Azure. Was there any follow-on actions that Wiz took based on some of the footprint available in AWS? Things like the exposed SQSQs?
Part of the work we do on our research team as part of Wiz is to figure out the source, the sort of cloud problems, whether they lie in the customer side or the CSP side, in order to also improve the service that we give to our customers. So in the Azure case, we also released an advisory for our customers and a control where they can find these sorts of misconfiguration themselves and help them with fixing these issues. And also, in any of our other findings, we always try to integrate those findings into the product and help customers figure out the sort of mistakes they do on their environment. Sometimes it's easier, sometimes it's harder. For example, the SaaS token example, as Nir mentioned, is very hard to track, and it's just made locally, and you cannot really track it easily. So some are harder to take care of, some are easier to take care of, but we always try to make sure that our research findings will also be available to his customers, and also to the entire internet. If we publish write-ups, we always try to make things as accessible to everyone as we can. So yeah, that's basically it.
Well, I'll just personally say it's a little bit frustrating that it's 2023 and we're still talking about public S3 buckets. Although one thing I did sort of wonder about is, if there may be some sort of sampling bias as you're looking at passive DNS logs and crawling HTML pages, like there may be a bias towards using public S3 buckets when you do that. So how do you think about like trying to really quantify the real proportion relative to possible sample biases?
Yeah, as always, when doing these types of things, there's always a sample bias because the internet is a big black box, and we just try to figure out what's going on. Obviously, these numbers are not comprehensive, but we try to basically tackle these problems from a couple of different directions. You know, also both DNS and Common Crawl and apps, and we constantly try to find new ways of basically scanning different parts of the internet, and every part will probably look different to the other part. So yeah, there's obviously a big bias everywhere, but we try to rely on public data and not just our own internal data, which obviously will have a bias for people who use CNAPs. So as always, we would definitely appreciate any input from anyone else. If anyone knows a different type of source or anything, it will definitely help cool the bias or maybe move it to a different place. But yeah.
Any more questions from the audience? All right. Thank you once again.
Thank you very much.